All right. Just so everybody knows, I don't do talks, so this is going to be great. All right, so yeah, I'm Andrew Lunsford. Poor font choice and size, the bottom there. I worked on Bluetooth on a project a while ago, and it was awful. It was probably one of the more difficult things we've ever done, just because, for many reasons. So there's incomplete resources out there. There's out-of-date APIs. They did a switch recently from normal Bluetooth to Bluetooth Low Energy. Examples were difficult to find. There was proprietary software like the Bean and things like that that seemed to have more everything. There's more resources, more examples, and I had a difficult time with it. So I ended up writing a blog post or two, and then was asked to do this. And when going through that, I found out that the worst part was that they only explained the client. And when you have a client-server interaction, with no explanation of that server side, you kind of just, everything was whatever, like, okay, you do this and then something happens. And there was no explanation behind that side, which, I'm assuming everyone's dealt with a server before, like a RESTful API. You either have documentation or something understanding what's going on there. So what supposedly helps you understand that is the Bluetooth GATT. It stands for Generic Attribute Profile. It's more like the generic attribute profile, and then they kind of made up some rest of some acronym. It's a hierarchical data structure that describes the client and server roles and how they interact. So this is obviously going to be different for every Bluetooth device you talk to. It's completely up in the air, much like a server always is. So there's a lot to understand there, and if you don't have proper documentation, you're definitely going to be banging your head against the wall in that sense. So a way to think about it is there's the GATT. So you have this big box of everything. You have your client and your server, equal parts of interaction. I found that you had about this much explained via Stack Overflow or the Android developer reference, and then the server was a black box. So I set out to try and understand that better, and ended up creating a little test project to actually use two Android devices to talk to each other, and one was the client, one was the server. And I think I gained more knowledge about this whole process of doing that than I did ever reading all the documentation and any example anybody had. And then, of course, like Google does, as soon as I figured all this out, they put out an example that explained everything that I talked about. So, now you're better off. So before we get started, there are some prerequisites. You have to be 18 and older, because that's when the BLE came out or was supported on Android. Before that, they used their old Bluetooth manager and things like that. So it was much less efficient, the difference between low energy and not. You have to have your manifest permissions, which is Bluetooth admin. You also need to access find location, which somehow is related to the scan results. If you don't have this one, you can't get anything, and it fails very silently and annoyingly most of the time. And then if you are Marshmallow 23 and and older, you need to have, or I guess newer, you need to actually have the runtime permissions, as you may know from everything else. So, and then now if you're doing the server side, if you're just talking to a device, this is not very important. But if you're doing Android to Android, your phone specifically has to support peripheral advertising, which I think on most things that are 23 and later will work. But it's one of those things you have to check per device. I mean, if you have an old device, probably not going to work, and you should probably get a new phone anyways. So let's go with that. Now, the way I'm going to structure this is we're going to walk through the scanning, configuration, and then actually sending messages. So if you pay attention in the bottom right of the screen will be a little Android or a little Bluetooth symbol. So the Android will mean this is what we're doing on the device, and the Bluetooth will be either an actual Bluetooth device or could be just another Android phone. But in case you forget, I made that cute little thing. So first of all, we got to set up scanning. You have your basic checklist of Bluetooth support. You have to have Bluetooth enabled, and you have to have your runtime permissions along with location being one of the ones you ask for. In my experience, Bluetooth is very, very fickle. If something happens pretty much at any point, if one of these checks fails, just go ahead and stop. Just restart everything because it can get into these weird states. I even had things that were configured wrong. You had to reboot the whole device when you're testing. Once you get it working properly, it shouldn't happen that anymore. But you need to be very strict because if you fail any one of these tests, then there's basically no point in moving on. So you have to like block the action or finish the activity or restart, whatever service you're running and that sort of thing. So the first thing we have to do is we have to set up filtering. There's many things you can filter on. You can filter your device address, your name. There's manufacturer data, which comes up with like UIDs, and there can be specific prefixes, suffixes in there that you can kind of filter out certain things. Interestingly enough, this works differently or not at all on a lot of devices, Samsung being great at everything. You have to do manual filtering sometimes. If you know exactly the UUID you're looking for, it's perfectly fine. But say if you have manufacturer data and it will have a portion of the UUID, like dead beef or something like that you're looking for, you have to do manual string filtering on a lot of devices because there's a lot of inconsistencies. So kind of be aware of that if you are doing something to that extent. And that would be something if there's a brand like Logitech, you're looking for your mouse, you're trying to look for this special prefix, you might have to do that manually. Otherwise, especially if you're using libraries that do Bluetooth for you, sometimes those will not work. So again, you kind of have to roll it back to the basics. So you have your service data and the UUID, which again are just more attributes in which you can filter on. So next, we're going to set up our settings. There is the match mode, which is aggressive or sticky. This really kind of not as big of an issue. I imagine in my testing, I had two phones next to each other, so it wasn't exactly the most important thing. But aggressive would be if it sees the device at all, that's a match. Sticky would be that it needs something more persistent, like a stronger signal. It can't be like a passing thing. So it's all in how you're trying to set it up. If you're trying to detect as soon as you walk in your house, you see your Bluetooth speaker, connect to that, and then maybe you want to go with aggressive. Or if you want something that's going to have a stronger signal, better speed, that sort of stuff, go sticky. There's a number of matches, how many times do you see that device in a certain interval, and then you have your scan mode. You can go with low power, balanced, or low latency. So low power is not really going to have a strong signal strength. Balanced will be somewhere in the middle, and low latency means that it's going to hammer it. So again, these are settings that will affect your scan results and your battery usage, more importantly. So being low energy, it's usually kind of better to stick with balanced or low power. But again, these are all just kind of up to you, really. All right, and then finally, we're going to have a callback. Everything in Bluetooth is asynchronous. Annoyingly so sometimes, because the way the callbacks come back, they can be very out of band, and you kind of need to track your state sometimes. You have to handle a scan result. So once you scan, you give it a callback, and then it's going to give you scan results. It can give them one by one, or it can give you in batches, and then it handles a failure. So once you do that, you can either act on those scan results, or you can just store them for later. The scan result will have things like the signal strength, how strong was the signal to the device. There's the Bluetooth device, which is what you use. It's a container to actually connect to it. You perform actions on that Bluetooth device when you have a result. And the scan record will actually have information about the Bluetooth device that inconveniently are not put on the Bluetooth device to pull. So you have this separation of data, which is something that's very strange to me. But the scan record, will have like the service UUIDs, the manufacturer data, the service data, and the device name, which, like again, it should be kind of on the device. But once you have all those set up, you can actually start the scan. So you use your filter, your settings, your callback, and then it scans forever. Somehow there's no timer on this. You have to manually do it yourself. So you actually, once you set that all up, it will scan forever, and then you have to post like a handler or something like that, depending on, you know, how aggressive you want to be or how long you want to run this. You know, if you have tons of battery to work with, you can make this run for 30 seconds or 10 seconds. You know, if the devices are right next to each other, like in this kind of scenario, then 2 seconds is probably fine. And you can also just, if you're looking for a specific device, you could just stop the scan as soon as you find it. So assuming you do find it, you're done, and that's great. Now, when you start scanning, you know, we're in an office, we all have computers, we all have phones, we probably have Bluetooth headphones, everything like that. You're gonna have like hundreds of results probably, which is where the filtering comes in to, if you know the UUID or maybe that prefix or suffix of the UUID, you can definitely start filtering those down, because otherwise you will get spammed very heavily, and manually sorting through those is definitely going to be a pain. So that's your basic scan. I know that was fast. That's just how I talk, sorry. So now advertising. We're going to switch over to the server real quick. And same kind of checklist for the server. You know, you have to have support enabled for Bluetooth. You have to have your permissions. The only difference being you have to have multiple advertising support. Now, I know that says multiple, but really this is the only check you have, and really all it means is that you can advertise, period. So this is where the newer devices might be needed to actually have that functionality. I think I was trying on a Nexus 4 or 5, and that was just not available. So yeah, probably newer phone. It will be needed for this part. So now we have advertised settings that we have to set up. There's your mode, which is similar to the scan mode, so it's either balanced, low power, low latency, that sort of thing. So it can kind of ping out very slowly to retain battery. If it's a server that's sitting there, especially if it's not actually plugged in, you know, like a mobile device like your headphones or whatever, maybe it wants to save some battery if it's not actually connected. So again, up to user preferences. Connectable. This is actually an integer. So you can set it to 0 and you can have it connectable forever. Now, again, this is obviously, if it's never going to close that connection, then maybe that's not the best for your scenario. You can have a timeout. And the timeout can be, connectable is true or false. Timeout's forever, what I was doing. And the transfer power level is basically the power going to the signal. Now, you know, low power is going to be a tiny radius, not very far, but if you boost it all the way up, I think it just has 3 modes. And if you have it all the way up, then it's going to be as strong as that Bluetooth, you know, adapter can send, and you'll be discoverable from a longer distance. Makes sense? So, sure.
I have a question.
Yeah.
When you say server, are you talking about like a device that is hosting a lot of connections? Like I was kind of trying to figure out like server, what do you? So,
yeah, in Bluetooth, it's really just the server is the device that is advertising that it can do a thing over Bluetooth. The client is the device that wants to do the thing. So if the client is your phone pairing to a Bluetooth speaker, the speaker is the server, even though it has nothing but a speaker. It's saying, hey, I'm connectable. Would you like to connect to me? It seems kind of backwards, because usually the server is the one that has like all the information and the data that you want to query and pull, and the phone would be the client. But the server is actually kind of the more dumb device. It knows how to connect to itself, and it kind of advertises these settings. But the client is usually the one providing most of the data. It seems kind of backwards to me, and that was, again, why I wanted to go into this whole interaction. Is that kind of?
Yeah.
Okay. All right. Thanks.
Yeah.
So yeah. So you set up your advertised settings, and this is just kind of not related to what you're advertising, but how you're advertising. And then once you have that, you set up more configuration, which is your advertised data. Yeah, usually this is actually optional to have a device name, which I think is kind of funky, because I feel like a device name is always helpful to know what you're connecting to. And then you have a service UUID. So again, that's something you can match on when you're scanning. Is if you find that UUID, you're like, okay, this is what I'm looking for. Let's connect to that one. So once you have those two, you create a server callback. We'll get to those in a second. And it has all the kind of like on this, on that, connection state changes, that sort of stuff. You take your advertising data and settings, and you add your service UUID, and then you start advertising. And you basically just open the GAT server and just start running. For now, it's just basically an empty callback, and it can accept connections, but it's not going to do anything with them. And that's actually quicker to get that set up, to get the actual server up and running. And then you have a server, which is locatable by the UUID. So now that we have that, half the equation, we'll actually try and connect to it. So scanning and connecting. Again, filtering by the UUID. Since we know if you just create a UUID, you set that in the server, you'll actually have that full UUID. It's very simple to connect to it. And you can kind of shortcut it by filtering to that UUID and then connecting to it directly, stopping the scan early so you don't have to wait that full timeout, which is very much more convenient than, say, having to poll or one of these more advanced scenarios, like if you're walking up to your house and you're trying to connect to, like I said, to your stereo or something like that. So once that's done, you connect to it. Well, what do? You have to handle all of your client callbacks. I think there's like 8 or so. There's a connection change. It'll be the first one you get. It'll say, hey, we connected this device. What do you want to do about it? And the fun part about this is that there are so many ways it can go wrong. There is basically, it gives you a new status, and the status is not one of 30, which is GAT success. You need to just disconnect and start all over. It's kind of a mess, but basically what I learned is anything other than that, and when dealing with Bluetooth, is everything sucks. So you basically just disconnect at the first sign of trouble and you bail early. You know, in this instance, we control both the server and the client, so it's just kind of a little more positive experience. But basically, if you don't get that success thing, you need to restart, reconnect, do whatever. I can't imagine doing this in a production environment and having a bunch of retrial logic going on. So yeah, you disconnect if there's not success. You disconnect if it tells you it's disconnected, which is weird because you just connected. And then you need to also not rely on any kind of state logic within the callback or anything like that, because there really isn't much of that. You have to track if you are connected locally. This is one of those things you have to have like a flag and say I'm connected, or however you want to do it. But basically, this needs to be your first check in any one of these callbacks. Like, if we are connected, continue, and if you're not, just keep bailing. So, and then you can't even just say, oh, well, it told me I'm disconnected. I need to just not do anything else. You actually still have to call disconnect on the GAT and close it out to make sure it's all nice and tidy and cleaned up for the next time you're actually going to try to reconnect. So that's the intro to callbacks on the client. So now we have server callbacks. The server has about the same thing. It's on connected state change, or on connection state change. It'll have a device saying, hey, we connected. But at the same time, you also have the successful connect or the success not, or failure in 18 million ways. So if you do have that one success state, you can actually take and then say, oh man, we got a client. Let's add that to a list of devices, because it does not track any of these things for you automatically. So if you have a connected client, you add it to your list of connected clients, and then if you have a disconnect message, you just take and remove it from some type of set or something. I think I usually do it by MAC address since that's unique. So yeah, we've now got scanning, we've got a client, we've connected, hopefully successfully. We add it to our connected devices list. And now we should be ready to start communicating. So I know I've kind of run through a lot of that really quickly, but and been throwing some words around. So here's a beautiful diagram that I made. We have our GAT server. That is the thing that is advertising. That's what we're trying to connect to. It can basically, this is basically a one-to-many on any one of these things. So the GAT server can add multiple services, different UUIDs, that sort of thing. And each service has a characteristic. The service does not really do much more than describe kind of what it is. And the characteristic is where you can actually start sending and setting data. And each characteristic can also optionally have a descriptor. Without the characteristics and the descriptors, you're basically just a device that exists. This would be kind of like a, what's the Bluetooth bean or something like that. So if you're basically just trying to say like a geotag or something like that, if you find it and exists, you know where you are. So if you see it, you're like, oh, I'm home, you know, like that's kind of a triggered device. And you can do operations around that, but if the service has no characteristics or descriptors, there's nothing else you can do. It's just you found it in a scan and that's it. But if you start adding characteristics and descriptors, you can actually start sending data back and forth, which is how you can, your phone can send your music to your speaker. Really should have walked this. Really should have organized this around speakers and phones. That probably would have been more easy to understand. All right. So now, on to character building. We're going to say, these are actually characteristics, but they have things like a UUID, just like the service, just like descriptors. Everything has a UUID that you can find, so you know you're operating on the right thing. So we have to set up our properties and our permissions. These seem a little bit redundant, and they kind of are. So you have property write and property read, permission write. You also have notify, and when you have read. And depending on what these say is what you can do, as it kind of describes. The property and the permission is a little bit redundant. In testing, I've noticed that they don't actually need both. Sometimes you can have the property and no permission, and sometimes you can have the permission with no property, which your guess is as good as mine. So you have those. We need to set write. We need to set permissions and the property, and notify. Now, what that enables us to do is actually, it basically tells us that this characteristic is able to be, written to. Without some of these and in certain combos, basically you're stuck. So if you don't exactly know which properties are set on the server, if you say don't have a reference for what's going on, you might spend a long time guessing. In changing these, when I control the server, if you change these enough times, the server has no idea what it's doing anymore and requires a whole reset. So you actually have to, killing the app was not enough. I had to restart the phone so it could figure itself out. So enjoy Bluetooth. So now, discovering services, back on the client. On the successful connection, we check the status. Like I said, if it's not connected and successful, bail out. What you then have to do is you have a reference to the GAT. You basically say GAT.getService, and if you know the UUID, you can just go ahead and access it that way. Otherwise, you can get services and loop through them and check to make sure that UUID matches what you're looking for. Now, we then have to find the service. Well, sorry, that was find service, and then we have to find the characteristic on that service. So you can see where this gets complicated and annoying, where you can find the right one or maybe not the right one. There's many places where this can fail out. And this is all kind of inside the callback to where threading becomes fun. And you may have to post a handler out because you're not supposed to do that much heavy lifting on the callback. And if you're doing light work and it's very quick, you might be able to get away with it like I did. But no, if you're trying to do something like stream some music, you might need to pop over to another thread so you don't get your callback all backed up. So just be aware of that. Now, once you have the service, you get the characteristic, and then you have to set some properties. So even though the characteristic is already set up on the server and not technically advertised, but it has the right property and the right permission set up, W-R-I-T-E, right? You actually still, on the client, have to say set write type to write type defaults, or there's a few other options. For some reason, that's very necessary. Instead of it just being kind of blind and either allowing it or not, you have to specifically tell the client's GAT that this is a thing. And then you also, if you want to get notifications on the characteristic, which basically is notifications on the server side, anytime something changes on that characteristic, you can then say notify, and the client will get the notification. Otherwise, the server can change the characteristic, and the client either might have to read it manually, say on a loop, something like that, but it's not going to get the notification as soon as the server says, hey, something changed. So we're going to set the right type of default, the characteristic notification to true on the characteristic. And then at this point, it's a good idea to actually save some type of state to your class, your object that's working with the Bluetooth. I like to call it initialized state, basically saying that once all these steps are done, we have succeeded in basically the foundation. We haven't really done much at work yet other than setting everything up. So once this is done, everything is good to go. But until all these things have happened, you won't be able to send any type of message or get a message, or the Bluetooth could be failed. So there's now two things. We have the Bluetooth is connected, and then it actually is initialized on that specific characteristic. So if you're working with multiple characteristics, you're probably going to want to keep track of all of those things. Theoretically, you shouldn't be working with more than one. Hopefully the device is simple enough to just have one thing to connect to if you're sending your music or your data or whatever. All right, so now that we have all that, let's get ready on the server to actually say receive some type of message. In this instance, we're just going to send simple text string. So what it's going to do is in the server callback, it's going to get what it's called the on characteristic write request. It comes in, and you need to check which characteristic that is. It has this bundled up, so you check the UUID. Somehow it doesn't reject it, even though it already knows which characteristics you have. So it's always good to check that. Reject it if it's not your characteristic, because you probably won't know how to handle that. And if it is your characteristic, the first thing you need to do is send a response. Now, this is not like if it's like a chat app over Bluetooth, it's not like responding to it. It's just like an acknowledgement that we did receive your message. So first thing you do is that. So you're like, okay, yes, this is our UUID of characteristic, and we want to say that we got your message. That's pretty much step one. Then the next thing we're going to do is we're going to read the value. It's just a byte array. You pull that off, and then for this instance, what I did was I just reversed the bytes to make sure that it was, like distinct when you get a response, so it doesn't think you just kind of bounced it back and you're kind of wondering if that actually happened. So I reverse it around, and what you then do is you take and set the value back on the characteristic, and then we'd use our notify. And then the client should, if it's set up correctly, get that notification. So back in the client, quickly we find the service and the characteristic. We convert whatever message from like an edit text or something to a byte array. We set the value directly on that characteristic, and then we call GAT write characteristic. And then that will give us our success or not, because the server has responded with that immediately saying, yes, this is my characteristic, we're connected, here's a response, and then we read the message. Once it's notified, we receive that, and then we get the value directly off the characteristic, and we convert the bytes back to string or whatever you're trying to do. So that, very quickly apparently, is how to communicate over Bluetooth. I know I glossed over a lot. There's definitely a lot more, like read-only, notify-only characteristics. For instance, say if you had a server that was broadcasting a timestamp every time something it had happened, whatever, like the volume changed on the device, and some Bluetooth devices you can change volume on there, and you want it to mimic back to the device, so you kind of just notify. It's not actually trying to read that or pull that on an interval. So you can have read-only, notify-only, and And then there's descriptors. I know we never got into descriptors because they are basically the same as characteristics and very pointless sometimes in my experience. Descriptors are one of those things that they are just up to the manufacturer. Some people use them, some people don't. There's a weird scenario where you can get in where the characteristic, you can enable the notification, everything on that, but if you never dig down into it and know to enable the notifications via the descriptor, via a special parameter in the Bluetooth spec, you'll never get any notifications on anything, and you will definitely hate your life for a while, because I've done that. And then one thing I purposely ignored is that there is a byte limit. You know, Bluetooth Low Energy is very tiny messages. I think it's 128 bytes, and if you have longer messages, if you're streaming music, if you're really chatty, you have to start breaking those things up and then sending them through a loop and then hope that everything works out okay. I mean, honestly, Bluetooth is a miracle. I mean, it's so crazy how some of this stuff works, but definitely longer messages are, a thing. You can easily see this if you just have a Bluetooth server and a Bluetooth client and you're just sending a really long text string. You can easily overflow that, and you'll notice that it just gets chopped. It doesn't matter what you're doing. You have to handle that manually. Same with descriptor handling. I mean, that is very, very highly custom to where every server is going to work differently and everything needs to be documented very clearly, or you're going to struggle to figure out how that works. Same with the read-only and notify. So, again, that's actually it. So here's... So yeah, I made this link slide, but obviously this is worthless since you can't click on that screen. We're going to post them in the meetup afterwards, so don't worry. Like, I know that this was a very high-level talk. I hate high-level talks, but I didn't want to put a bunch of code on the screen because that's hard to read. This was all pulled from my part 1 and part 2 post, and I've linked up the stuff. We'll put this in the meetup notes so that everyone can find it later, so you're not completely lost. But questions? I feel like there might be a few. Our ciphers.
So do you think most of your challenges were around like the Bluetooth spec or just like Android Bluetooth specifically?
It was a little bit of both, actually. Are we using Catchbox for this? No. Anyways, he said if there was, I'll just repeat for the mic, was the challenge more Android or Bluetooth spec? I think it was both, because there was very little documentation. When I was on this project, the server was very poorly documented, so it was a lot of guessing and checking. And when the device can easily get out of sync, and like I said, you put some settings in there and you don't have the settings right, and then using certain libraries, like there's an RX Bluetooth, I think, that was awful. You would be like, oh, RX, that's great, but what it tried to manually filter things for you, and it was not doing it correctly, and it was very aggressive at dropping out what it thought were incorrect matches, so I ended up having to roll my own, which is everybody's favorite thing to do. So I struggled with that. I struggled with all the libraries. There was very, very bad documentation on some of these things on Android's side. That just made everything difficult, and like I said, there were examples, but they were for the old Bluetooth, so I had to change everything, and then I was like trying to use something the method didn't exist, because it was the new Android BLE manager, and like if someone's just talking about it, you're like, well, which one are you talking about? And then there was the spec. We ended up having to, on this project, use those descriptors. There is a special flag in there somewhere. It's like 2902. That's how bad it is. I remembered it. Is that you had to specifically enable that descriptor in the spec, and it was not really clear why. You were just like, oh, well, that's just how the server is, but that was not obvious until days later after reading. So it's pretty tricky all around.
So it's not just like an Android thing, it could be like implementing Bluetooth on like any other platform.
Yeah, I'd imagine it's tricky on any platform. The app I'm on right now is actually, we deal with a Bluetooth mesh that's proprietary. Luckily on the Android side, we have a library that takes care of some of it. But then we are also doing an iOS project that also deals with the same thing, but they're not using a library. And I know what's going on because of all this, but I can tell that, you know, like they still have the same callbacks and the same tracking of state of connected and retries and that sort of thing. It's just, Bluetooth is tough. Like next time you stream anything over Bluetooth, just stand back and like, I'm being amazed. Like that's the only thing I gained out of all this is pure appreciation. Yeah. Anybody else?
Can you go more with the test bed? What it is?
The test bed is actually what I was exploring and what is backed, what's backing the blog post and this talk actually. So it's a publicly available GitHub repo that has all this stuff that I've been talking about, setting up a server. There's a server activity, client activity, that sort of thing. And it's really good to just, I would recommend reading the blog post because it walks you through. It's definitely like a lot at once because of the way the callbacks work, and it's so asynchronous and there's not really a logical flow. And the blog post kind of tries to walk you through that step by step, you know. And yes, it just like my talk, it switches between the two. So you have your building blocks, you know, you get ready to scan, then you build a basic server, and then you get some attributes ready, then you try and find them and work with them. So that's what the test bed is. And it's a really good starting point, and that was kind of the whole point. I really didn't, you know, I was kind of make a blog post, but you know, I just wanted to figure out what was going on, and it took me a while, and that's kind of the end result of it. So I just kind of pushed it up publicly for everyone. So yeah. Anybody else? Really? Was I that clear, or do you just not like asking questions? Because I don't feel like I was that clear. I really like the whole server client thing is weird. I should have done a whole speaker versus a phone thing.
Well, I have a question.
Sure.
In terms of, I'm relatively new to the Bluetooth aspect, well, not Bluetooth, but when you mentioned characteristics, can you give me an example of what a characteristic is? Like in terms of, does that mean like in terms of it gives me the option to play music or to receive like read only? Like what are the characteristics?
Yeah, so it's kind of characteristic, much like descriptors, are just kind of a value on the service. So they're kind of just a dumping ground. You know, it's like you have your Bluetooth GAT, which is your phone's Bluetooth radio receiver, basically thing, just saying, we got something, and then it's like, but I have this service, and you find that service, and then on the service you have characteristics. Now you can have multiple ones. I mean, as many as you want, really, until you run out of UUIDs. And which would be impressive, honestly. So what you do is you find that characteristic. That's how you send your information. There's not much on the characteristic other than some little things that are not really important. There's a UUID, there's some other things, and then there's just the value, and that's your 128 bytes available. And you know, when you connect with the client, you find that characteristic, the server, and then you basically have a handle on it, and then you say set the value to this, and then you write it out. And then the server can then to do whatever it wants to handle that. It can read it off, it can return it back, it can do nothing. You know, it can just receive it, it can just read it, and then never respond other than the fact that, you know, acknowledging that it did receive a thing. In the same way with the descriptors. You can write data to descriptors and you can write them to characteristics. They have the same limit, so there's really no benefit to just digging down to a descriptor. It's going to have the same callbacks. It's going to be on write, on read, that sort of stuff. And that's just how you transfer your data. That's pretty much it.
So is there such a thing as a kind of like a standardized characteristics or like a given code, which means like I can read your context or where, like when you connect to your car Bluetooth, it says like, oh, I want to read your phone's contacts or something else. Or is it done somewhere else?
It's all proprietary. Everyone rolls their own thing. There's no like, characteristic 1 is phone information or device information or anything like that. Like you get the name and you get the UID. You have some manufacturing data, but again, that can all just be whatever they decided to stamp it with. There's no standard. That's just why you have to know. Like I can't imagine trying to figure out how to connect to my car stereo or my mobile speaker or anything like that without having some knowledge of what the server is doing. Like you'd basically just have to guess. You'd have to get in a Faraday cage and So that way you only find that one device instead of the 800 other ones you'd find in his office, and then start guessing at everything. You just list the characteristics and be like, maybe this works, I don't know. But they can all do it a different way because each server is so custom. I mean, I would change one thing and I would break my own server, and I was the one controlling it, and then I would never be able to connect to it and have to reboot the phone, and I'd reboot the client, and then I'd try and connect to it again, and maybe it worked, or maybe I screwed something up, and I was constantly, resetting everything. So there's not a lot standardization going on there, unfortunately. So, yeah. Anybody else?
So there are actually like there are standards. They don't exist so much in BLE. BLE is like a subset of classic Bluetooth.
Oh, okay.
And the thing called the GATT, it's actually the GATT profile.
Yeah.
And what the GATT profile is it's actually a sub definition of a normal Bluetooth profile. So if you go look at the Bluetooth spec that the Bluetooth working group posts on their site, they have a whole bunch of profiles for like headset and contacts and music and streaming and all those types of things. Those are classic, and they are typically standard, but you can't connect to them with LE, right? So usually if you're connected to like a speaker or like your car and you're gonna be doing streaming, you actually have a socket and you're writing bytes through a stream.
Right, yeah.
And there's various other protocols and profiles that you can have for like the headset and download contacts. There's like an object passing profile that's kind of like SOAP-ish that defines how objects are passed back and forth over that socket. BLE has this GATT profile, which is really a definition of how over the socket you're going to transfer data and characteristics. So a service is really just a definition of like a REST API, for instance. Like when you do REST, you have a definition of like you have a route, and then you have a definition of what happens when you put, post, get, delete, all those things. Usually you have some JSON, and the data in the JSON is kind of your, like, this is what you can give me, and I will do something with that. Service ID is a definition of what you have. So if you have a service ID and it's published, and there's a bunch of them up there, but they're all very generic, like this is a thermometer, and you can, this is what the thermometer service ID is. And a characteristic is temperature. So they're all very basic, but most everybody defines their own kind of proprietary stuff. But a service ID is basically supposed to be a fixed, this is a set of data that I allow you to either read and write from, and then characteristics is just a list of them, and descriptors make it more complicated. But there are standards that are just not really useful and nobody uses.
Man, where were you like a year ago?
Probably quitting a Bluetooth job.
I wonder why. Yeah, that was one of the problems I ran into is everything I found. Everyone's like, yeah, just open the socket. And I'm like, what are you talking about? That doesn't exist on BLE.
I had it easy when I was doing it because I started out doing socket programming. I'm like,
Yeah,
I'm
I can imagine.
I'm an old guy, so
Yeah, coming from
Like, not as smart.
coming from old Bluetooth to new BLE would have been a lot easier than coming from nothing to BLE, for sure.
Some of it's timing too, like it's really difficult. The projects that I worked on, they had really unreasonable expectations about what they thought was going to happen in a certain amount of time.
Like, yeah, latency becomes a huge problem.
Yeah, no, it's very difficult. If anybody's going to jump on and do projects with this kind of stuff, I highly recommend go to the Bluetooth working group, actually join and become a member because you get access to documentation that you don't really just get from their site. You can post questions to their blogs and whatnot. And O'Reilly has a pretty good book called Getting Started with Bluetooth Low Energy, which kind of doesn't deal with code and it doesn't talk about Android specifically, but it goes through all the different communication and hardware layer stuff that goes on between server and client when they're negotiating. It talks about security and authorizing pairing and things like that. It really made a lot of that stuff click for me before I started actually trying to work with Android.
Yeah, no, that sounds great, actually. Hopefully I don't need that now, but it does sound like a good
It's
resource.
a good feedback, guys.
It was,
Actually, it kind of goes through like a lot of paradigms you can set up, like clients broadcasting and servers not broadcasting until they receive broadcasts from clients so they can remain hidden. Stuff like that.
Is that using classic Bluetooth?
Bluetooth LE.
A Bluetooth LE?
So
It sounds like the client turns into a server for a second, and then the
Because you can operate.
server. Yeah, right. Yeah, all you do is split this. It's nothing.
But there's
That's
a whole
interesting.
bunch of cool stuff in that book.
Yeah, yeah, that sounds cool actually.
Not to hijack your topic.
No, again, like I said, I wish I knew all that stuff. I wish I knew this a year ago, but I had to figure it all out. All right. Does anybody else have questions for me or him? I don't know. All right. Cool.